My name's Daniel. I'm from New Zealand, not Australia. I get it every day. So I'm just here to talk about actually 3 products, but I'll keep it mainly on one. But they're innovative nanotech coatings. I have 2 companies, Window Insulation and Max Insulation. So I'll talk you through this presentation. This is one I've done recently, but the market problem we face is the scale of remedial works. Transport accounts for 1/4 of UK's green gas emissions. We've got to do 1.8 house refurbishments a minute to meet the deadline. There's 600,000 government buildings to decarbonise 1.2 million private sector buildings. Cost of current improvement measures is very prohibitive for retrofitting. Design of current improvement measures is prohibitive in terms of time and cost. There's a lot of disruption to occupants and companies with retrofit measures. And supply shortages, price increase and longer lead times are a problem as well. Creating raw materials like glass and aluminium use a lot of energy. So on the 1st of April 21, Pilkington put their glass prices up 35%. And then on the 1st of May, 1 month later, did another 15% on top of that. And then trust in supply chains, things like Grenfell and making sure that people are confident in what you're using. So the solution is to retrofit buildings to save energy, money and carbon, repurposing existing materials and equipment, rapid design evaluation and proposals for deployment, confidence in independently accredited materials and low disruption. So like with an airport or a train station or a hospital, you have to do these processes or installations whilst it's still in operation with low disruption. So the first product here, Window Insulation, is a retrofit application. It goes onto any glass, U-value improvements onto existing windows, 20% energy saving through the glass in winter, 40% in the summer, contributes to EPC point improvements. It blocks 99% of UV, which causes damage to skin, eye and furnishings. And to give you an idea, 4mm heritage glass, single pane, cuts about 15% of UV. This, when applied to heritage glass, cuts 99%. So it stops things from fading, stops skin and eye damage risk. Blocks over 80% of infrared, that causes the overheating. And again, if I use 4mm glass as an example, it cuts around about 15 to 20% of IR. Put the coating on, it's over 80. Up to 50% reduction in condensation, which reduces mould growth on the glass. Minimal change in visible light, and it's less than 1% embodied carbon compared to replacement. Just a quick flavour of the technology. 1969, Neil Armstrong walked on the moon. They pressed gold onto the inside of his glass visor, and this was the first time this technology was used. Pilkington glass, 1970s, came out with a dye. Moving on, window films came out, but window films are very soft and susceptible to damage. The glue cooks. But they've been used throughout the ages. And then in 2000 was a tsunami in Japan, where they had an energy crisis and health crisis, and the Japanese government commissioned the R&D departments from Japan to collaborate, and this is where our product was born. 2017 in Canada, a lot of research. So the product's been used in 37 countries for over 20 years, but a lot of Asian testing. American and ISO testing was done in 2017. We started the journey in 2020, comparing glass manufacturers and other coatings, and we secured the rights and distribution for the Japanese product, which is what we're talking about today. Now we're Waits Innovation members, doing work for Royal Shakespeare's Company, City of London, Amazon. These are all recent activities. HS1 are installing onto train stations, and HS2 have just installed onto site cabins. And there's a lot of other things going on. So this is the most expensive building ever built in London. It's the headquarters for Bloomberg. It's also the most sustainable building ever built in London. So we designed and did this without ever walking into the building or ever having a drawing from the building. We did this, and we can calculate the glass, or the energy saving through the glass roof. You can see the £80,000 to reduce overheating, improve well-being, low disruption and accredited supply chain. So interestingly, no drawings, not even going into the building, but we had the glass specification, we built the model, and we could rapidly design the improvements. This is Toyota's head office for Europe. It's in Belgium. So they have a problem with overheating. in the server rooms and in the restaurant. So we did the design again without the drawings. You can see here the installation on large format glass, so we're doing trials with them at the moment. There's 53 factories to do. This is heritage listed building for Oxford University. This is actually an archaeological environment with books and things. Interestingly, we've got a demonstration which we can show later in terms of energy saving. This is a solar meter, the wee video on the side. It's measuring energy through glass. It's a single pane. So what you'll see, I might have to just describe it, but when the video starts, I'll just mute that. So it went from 139 watts per square metre down to 30. So that's with the coating above and not below. So that's the amount of energy going through the glass. We've got thermal imagery camera images and other things which we can demonstrate. And what we do is temperature logging. So at the moment with this particular site, there's a 7-degree difference with and without the coating. So we do temperature logging. And we also put these little colour charts in the glass where one goes on coated glass, one uncoated glass, and one in the drawer. And what happens after about a month to 6 weeks without the coating, the coloured picture goes white, because that's what's happening to obviously your furnishings and your skin through older glass. And we're demonstrating the advantages. So we're doing a number of projects at Oxford University, Imperial College. We're the only listed energy saving product for Network Rail. We installed onto Buxton train station under an innovation grant. And they turned the temperature down. It was in winter, 5 degrees on the next day. We've installed onto the site offices for HS2 at this is Curzon Street. We did Washwood Heath. So we're doing data logging, looking at all of the different site offices. Midlands Art Centre, sorry, I'll just touch on this. This is interesting. It's a very complex, older building, and we're looking at different savings through the windows. You can see with this sun model, we can say where the priorities are. So most of their overheating has occurred where it's red. So we can prioritise. We're also doing work on the solar panels with the solar coating, which is the next one I'll talk about, and a thermal paint as well. So the other thing that's quite important is to be able to monitor old equipment. Problem is, heat pumps, solar panels and other equipment, people don't understand or know what's going on, whether it's broken, what energy is being used. So we've got a device where we swap out the isolator, connect it to the Wi-Fi, and we can actually understand the usage patterns. So we're doing this program on site. We work with a lot of different universities in terms of testing and projects, third parties, Guys and Thomas Foundation. We're listed with UK Green Building Council, various grants and energy companies listed there. So that's product one. So the other ones are a little bit quicker. All of these are available in demonstrations out here. They're really quite interesting. Max Insulation has 54 patents attached to it. So essentially, the insulation types we know are typically 4 out of 5 insulations we use are plastic-based, so they're flammable. The last one being rock wool, mineral wool, is not very efficient. But what we're talking about today is a liquid ceramic insulation. So we coated a house in Nottingham, and essentially this was part of a research program. I've got a lot of data on this, but the long and the short is 2 millimetres of thermal insulation equals 80 millimetres of rock wool. You can see on this one here, if you put 3 mils on, it's equal to 110 mils of rock wool, which is what you would normally do. So this would be, if you're refurbishing this house to get it up to standard, you're putting this rock wool on and then you're rendering it, or you can paint it. Nice and easy. I've got quite a good demonstration in the other room. So this is a container, shipping container, coated and uncoated, measured. So there's conversations with ZPN in terms of developing and controlling heat with their equipment. There's a few other things, site sheds there, and you can see there's a bus. This is coated on a roof, and you can see the thermal image difference. So there's a lot of research there. We've just installed onto British Sugar and a lot of drying units. We're about to install onto British Salt. The product's completely specified across the new facility in St Helens. These are some other projects. This is oil and gas in Africa, offshore for BP. These are pressure and big transformers which have been using it. So the product's extensively used. Here's some of the clients. So essentially all the oil and gas companies in the world use this product. The BAE, Stena Line use it here in the UK. So it's a very well-established, well-proven product. So it's got a lot of history. Nice product. So that's number 2 product. Number 3, and this is the last one. This is a patented coating that enhances solar panels. So the first thing is with a solar panel is, or if you use your car as an example, in the winter, if it gets dirty and someone writes clean me, you clean it. The problem with solar panels is people don't climb on the roof every 3 months and clean their solar panels, so they get soiled and dirty. So you lose approximately 30% of your energy. So on a house in the UK, if you there's 1.5 million houses in the UK have an average solar panel array that gives a £1,000 contribution, but if you don't clean the panels every 3 months, that goes to £700. So you lose £300 worth of energy without cleaning. So what the coating does is very unique. It does 3 things. First thing it does, just a bit about the product, it's patented, there's over 10 million square metres installed globally. It works on solar panel glass, but it also works on mirrors and polycarbonate, so you can put it on CCTV domes, plastic. The product, the first thing it does is it's super hydrophobic, so it's self-cleaning. So if there is materials on it, if it rains, it'll clean. It makes the surface anti-static, so things don't stick to the panel. And the third thing is it removes reflection, so that increases or boosts the energy production. So if we go back to the house example, if you had an opportunity to make £1,000 a year in energy, by putting the coating on, new or old panels, that would go to 1,050. And instead of losing 300, you're essentially maximising the use of the panel. So you're saving £350 per year by installing the coating once. That's not including cleaning costs. So that's moved very, very quickly. I've got lots of other information I'm quite happy to go through. But we've got some quite nice demonstrations, literature, other project reference information. I'll invite any questions. I hope I'm all right for time. There we go. Look at that. I've answered all in one go. We've got some nice videos rolling on the large screen showing installations onto HVAC equipment, solar farms. With the window coating, it's got a lot of background there as well. Yeah. If we have some more time, I can click some more slides I've got here. So another project down next to Exeter Airport is Hampton by Hilton. Total Fitness. I've done a lot of modelling for all of those sites. Bristol Airport is another one. First of 73 NHS hospitals, high-rise buildings. So yeah, there's a lot of work we're doing. The thing is being able to rapidly digital twin a building. You can then define the products to improve the energy efficiency and other things.
Daniel, we can actually get a cost in on any building quite quickly with this imagery carving.
Yeah, so essentially we can design typically in about 24 hours without any drawings, without ever going to a site. We can model it and measure the windows, for example, and the building fabric.
Do we need any additional information then to gain the savings potential of each of the products? Or?
We can give estimates, which is sort of based on assumed data. So before going to a client or to a meeting, we can take a demonstration equipment and we can go saying, without going right into it. So by getting more information from the client, like energy bills, we can be more accurate, and if we understand the equipment that they use. The difference is with the window coating, for example, is you get twice the energy or twice the dollar value saving if you've got air conditioning, which is a commercial building, non-domestic. So the return on investment for a non-domestic building for the window coating, for example, is 1 to 3 years. With a house, it's 3 to 5 because you're not paying for the air conditioning. The thing is, with us insulating our houses and with summers getting hotter and longer, we're turning our houses into a hot box basically with all that insulation, and all the heat goes through the window. So we've got a demonstration. We've got all different window types: double glazing, single glazing, glass, and other things, shot frontage glass. And it's very clear. You'll see with the heat lamp, you can see with and without the coating the difference. And we've got another device that can measure any window. So yeah, thank you. Anybody else? Please.
The brochure says for approved contractors only can install it.
Yes.
So what's the percentage of installations that happen with third party?
Yeah. So,
and what's the process for approval?
sure. So for the window coating, we have GQA, Glass Qualifications Authority. It's a bit like a driver's license. So go through a training program where there's theory and practical. It's like, although the coatings, people think are quite simple, it's like doing a car windscreen. Would you do that? Would you replace your own car windscreen? The answer is no. You'd get a professional, and the reason being is, in terms of preparation, priming, cleaning, it's an important application. If it's not done correctly, it's just like a car windscreen. You don't want to jump on the motorway. It's the same principle. You've got to be quite capable. So we have a training provider, and it's almost like a driver's license at the end. It's a independently accredited card which has a unique number, and we have with the different products, different training and different levels. So with the window coating, it's level 1 and 2. 1 would be a domestic or smaller window size. So we've got different window configurations and Velux window with it under 2.5 square metres. But then level 2 is large format glass, commercial windows, Velux glass, sort of other considerations. So that's the process, trained operatives. So we work with partner companies, work with their teams to go to market.
Is there an impact on the optics? Could you use it for an automotive application?
Yeah, in terms of optics at visible light, you lose between 5 and 8%, for example. So it's like your driver's side window. It's a very light tint. It's being used on bullet trains in Taiwan, Singapore and Japan. We've got videos of them putting on buses and things. We've actually been asked, because the thermal paint can go on the roof and the window coating can go on the windows for buses and coaches and things. So we can measure, we've got a device out here that passes lasers across the glass and it measures those parameters, and 100% of any window, we get an improvement. Even if it's got a window film. All these windows have window film. We've coated 2 windows over here, and you can use a thermal imagery, a split meter or a solar meter, and you can see it's just night and day with the coating. So if you're interested later, grab me and we'll show you over here. Even though it's got a really high spec window film, the coating does a significant improvement even further.
The high temp ceramic insulation.
Yes.
What temperatures does that go to?
So service temperatures, -62 and up to 260. So I've got videos of them installing it in where there's snow on the ground, and I've got videos of them installing it on hot pipes. So it's been used in the Middle East, been used in cold places like Russia and places like that. I've got lots of videos and installation information. It's for industrial applications. So furnaces and things, hot pipes well over 100 degrees service temperatures, because it's not just an energy saving, it's a safety. So for British Salt up in St Helens, which is a tartar facility, they've got hot pipes, and it's for although they want to save energy, it's for use as operative safety. The other thing as well is if you use pipes as an example, what you get is CUI, which is corrosion under insulation. So when you put lagging on a pipe underneath, it's hot and cold, it sweats and it corrodes. So with the oil and gas companies, they remove all the rock wool and other things, put the coating on. So we're working with BAE, for example, or military applications where they have gassing and VOCs coming off insulation, and where there's product zero VOCs. It's actually approved to be used in confined space. Good.
Is that a line of sight application?
Beg your pardon?
Is it line of sight application? Can't do internal?
Yeah, it's internal. Yeah, you can use, with the American product, the spray, it has to be sprayed. There's larger format application, but there's confined space. There's a special hopper gun and way of doing it. In terms of interior and confined, we've got things where they put on aircraft carriers and things. In the aircraft carrier, we've got lots of references and videos. Quite cool, actually. So, all right. Any other questions? Like I say, we've got some demonstration things over here. So just come and grab us. There's quite a bit of literature and things as well. So, that's good. I didn't run over my time, did I? So that's... Yeah, well, that's good. I usually do. But it's usually I've got like a 10-minute pitch or something. But yeah. There's only usually one product. So, good. Well, thank you.